Good morning, this is Ms. Trangle. This is going to be the 3-4 video. 3-4 can tend to be a little challenging, so please reach out if you need help. You can email, do a Google Meet, whatever you need. So to start with your notes, please make sure you're putting the date and subject 3-4 proofs with perpendicular lines in the top right. And then you're going to set up your lines, and then you're going to copy down the essential question or EQ for today's lesson. So the EQ: what is true about perpendicular lines? So it's probably been a little bit since you talked about it in algebra class last year, but what is true about perpendicular lines? Our learning target, we're on 3E. I can write proofs for perpendicular lines and solve problems involving perpendicular lines. Then this is going to be a big question that you need to be able to answer that we're going to work on. What is the shortest distance from a point to a line? So basically, what is the shortest distance from a point to a line? I'm going to summarize this vocab, but you do need to write down distance from a point to a line. So the shortest distance is a perpendicular line segment. So if you think about line K, I'll make that green, line K as your line, and point A as your point. The shortest distance from point A to K, right? I could go like this, I could go like this. I could make all kinds of lines from point A to line K. The shortest possible line is the perpendicular segment. How do I know it's perpendicular? Right here, AB, it has that right angle. Okay, so perpendicular segment is the shortest way from a point to a line. That's basically what that is saying. All right, then another vocabulary word, so this is still vocab, we're not to the examples yet, is perpendicular bisector. So please make sure you're writing down perpendicular bisector. I always get questions on quizzes and tests. What is a perpendicular bisector? All right, so make sure. So what is a perpendicular bisector? All right, so it says right here, so draw the picture, write the 2 bullet points. So N, I'll make N green here, line N is perpendicular to PQ, right? It's perpendicular, we see the little right angle mark, and N passes through the midpoint, which is point M. So these two segments are, PM is congruent to MQ, like 5 and 5, 10 and 10, 15 and 15, they're congruent. So that is what a perpendicular bisector is. So line N is the perpendicular bisector. Okay. We have a couple more vocabularies and theorems, so it's up to you. There should be something written. So for linear, if it was me, I'll circle what I would write. Linear pair perpendicular theorem, and I would draw the picture. And basically it's saying if angle 1 is congruent to angle 2, if they're both equal, then G is perpendicular to H, which makes sense since they're a linear pair, they have to add up to 180. What's 180 divided by 2? 90 and 90. All right, perpendicular transversal theorem. So write the name, draw the picture. This is saying, this is what I would write. I would just write this part. If H is parallel to K, and they're marked as parallel with the arrows, so H and K are parallel, and J is perpendicular to H, then J is also perpendicular to K. So it's kind of like the transitive property too. All right, last one, lines perpendicular to a transversal theorem, and I would draw the picture. If M is perpendicular to P, and N is perpendicular to P, so if M and N, I'll make those green. If these are both perpendicular, which they are, they're marked as being perpendicular, then you can also say that M is parallel, we'll add that to N. Okay, so make sure you have something written for all 3 theorems. All right, let's look at the examples. So I do want you to sketch the diagram and write the question. Find the distance from point A to line BD. From point A to line BD. Okay, and just kind of sketch the graph. It doesn't need to be perfect. or you don't need to use graph paper, but sketch it, what it looks like. Now, we just talked about in the notes that the shortest distance, we want the shortest distance from point A to BD should be the perpendicular. So here is point A, we're going to travel all the way. We want the distance of AC, the distance of AC. So I'm going to be using my distance formula, in case you've forgotten that from chapter 1. It's x2 minus x1 squared plus y2 minus y1 squared. And I'm going to use, I want the distance from A to C. So point A is negative 3, 3. And point C is 1, negative 1. So I am going to label those x1, y1, x2, y2. And then I'm going to plug into my formula. So for x2 should be 1 minus x1 is negative 3. All right, then I have two negatives in a row, 1 minus negative 3. I'm going to change both of those to plus signs. My second parenthesis, let's find a different color here. y2 is negative 1. My formula has a minus, y1 is 3. All right, then I'm going to do the parentheses. So 1 plus 3 gives me 4. And negative 1 minus 3 gives me negative 4. Then I'm going to square those. 4 squared is 16. 4 times 4. Negative 4 squared is also positive 16. A negative times a negative. So I get the square root of 32, or 5 point whatever that would be. I'm going to leave mine like this. So that is my final answer, square root of 32. All right. Example 2. Use the diagram to prove the perpendicular transversal theorem. So I do want you to write the problem. Given H is parallel to K, J is perpendicular to H, prove that J is perpendicular to K. And then draw your diagram as well. Then I'm going to be doing a 2-column proof. So I'm going to go ahead and set that up. I'm going to use S for statements, R for reasons. I always want to start with what was given. So I'm going to go ahead and start with H is parallel to K, J is perpendicular to H, and my reason is given. Okay, so let's think about what else we know in this proof. So it's marked on my diagram that angle 2 up here is a right angle, right? Angle 2 is a right angle. What else? If my goal is to prove that J is perpendicular to K, I need to kind of connect angles 1, 2, 3, and 4 to 5, 6, 7, and 8. So since I know that angle 2 is a right angle, I'm going to also talk about angle 6 because that will connect those two parts. So I know that angle 2 is congruent to angle 6. How do we know that? What type of angles are 2 and 6? This is something you should know. So they're corresponding angles. All right. Then I also know, so I know that angle 2 is congruent to angle 6. I also know that angle 2, it's marked on my diagram, is 90 degrees. So angle 6 is also going to be 90 degrees. So I'm going to say angle 2 and angle 6 are 90 degrees. That's basically the definition. Or that's kind of given in the problem. So I'm going to put given because that was marked there. Okay. Then, or we could put corresponding angles too. So because angle 2 was marked, but angle 6 wasn't. So I probably would accept kind of either. All right. Lastly, if angle 6 right here is a right angle, add that to our picture, then that means line J is perpendicular to line K. And I'm just going to say that's the definition, right, of perpendicular lines, that they cross at right angles. So if we have a right angle, we have perpendicular lines. So pause the video if you need any more time for the proof, or if you want to rewatch it. Otherwise, I'm going to move on to example 3.